Hello, this is Anbachelvi R from Heroes and the Technology. Now we are going to learn about amplitude modulation. In the outline of modulation, analog modulation and digital modulation. Modulation is the process of encoding information in a transmitter signal, and analog modulation AM is amplitude modulation, frequency modulation, and phase modulation. Digital modulation is the process by which some characteristic frequency phase amplitude combination of a carrier frequency in the with digital signal. Modulation of operation of varying amplitude frequency message signal. The phase band signal means is the transmission of a signal in a original unmodulated form, and a baseband signal can be analog and modulated. An RF power amplifier. RF power amplifier frequency signal to a higher power signal. Time and digital only represent a subset of values in the chosen phase amplitude combination pair of carrier frequency in vary in accordance with a digital signal, one consisting of coded pulse or state. Frequency shift gain and PSK phase shift gain. There are the three properties of a carrier signal: amplitude, frequency, and phase. Thus, they are the three basic types of analog modulation. First one is amplitude modulation. Amplitude modulation is the modulation technique used in electronic communication, commonly for transmitting message with a radio wave. In amplitude modulation, the amplitude of the wave is varied in proportion to that of message signal, such as a audio signal. And frequency modulation means the frequency of the wave intensity of the modulating signal. The advantage of frequency modulation is and decrease the noise, and there is a significant increase in the signal to noise ratio. We can also reduce the noise by increasing the frequency duration. Application of frequency modulation is the such as radio broadcasting, wireless communication, and audio transmission. FM is the user for radio broadcasting. They deliver high quality sound and music over long distance and in the noise environment. Modulation is the modulation and the pattern tool for conditioning communication signal for transmission. It encodes a message signal as variation in the external space of carrier wave. Phase modulation is the principal for angle modulation together with frequency modulation. Examples are and quadratic amplitude modulation uses both phase and amplitude modulation to create different binary state for transmission. Used by the changing the shape of the carrier wave. The process modulating signal is the mean by the process of low frequency signal on a high frequency carrier signal, and the process of varying the RF carrier wave in accordance with the information in a low frequency signal. Analog modulation is the frequency modulation and its advantages of decrease the noise. There is a significant increase in the signal to noise ratio. We can also reduce the noise by increasing the frequency deviation. It also reduces the interference by the adjacent channel is the band. Amplitude modulation is the process by which the wave signal is transmitted by modulating the amplitude of the signal. It is the often called AM and is the commonly used in transmitting piece of information through a radio carrier wave. Amplitude modulation is the most used in the form of electronic communication. Types of amplitude modulation: double side suppressed carrier modulation DSB-SC, and SSB means single sideband modulation. VSB means vestigial sideband modulation. The advantage of amplitude modulation is the easy to implement, and the disadvantage of amplitude modulation when it is come to power usage it is not efficient. The advantage of amplitude modulation: demodulations can be done using a few components and advantage. And disadvantages it requires a very high bandwidth that is equal to that of the audio capacity. And the message or baseband signal EFT. The modulation is defined as the process of low frequency signal on a high frequency carrier signal. This is the process of varying the RF carrier in occurrence with information in a low frequency signal. And this is carrier signal modulation. This is the process of imposing an input signal onto a carrier wave. This is called the modulation. In the modulation changes the shape of carrier wave to somehow encode the speech or data information that we are interested in carrying. Modulation is like hiding a code inside the carrier wave. Power T is equal to AM cos AM is equal to 3, FM is equal to 5 at here. T equal to time equation to represent the carrier wave, and there is another wave function. So this is the amplitude modulation is equal to the ratio of actual modulating frequency to the maximum modulating frequency. The envelope of the modulator signal. The following two requirements are satisfied. The first one is the carrier frequency Fc must be the much greater than highest frequency components. FM frequency modulation of the message signal is the example of Fc greater than FM. The second one is the modulation index must be less than unity. If the modulation index is greater than unity, the carrier wave becomes over modulated. Amplitude message with the radio wave and amplitude modulation the amplitude. The wave is the varied in proportion to that of the message signal, such as the audio signal. This is the technique contracts with the angle modulation, in which either the frequency of the carrier wave is the varied frequency modulation, the phase modulation. The perfect modulation standard of amplitude modulation. The value of modulation index should be 1, which implies the percentage of modulation should be 100%. For instance, if this value of less than the modulation index is 0.5, then the modulating output would like following it called as the modulation. The types of amplitude modulation: double sideband suppressed is a carrier DSB-SC means double sideband suppressed carrier. Introduction mathematical expression. And second one is double sideband carrier sideband full carrier. The traditional amplitude modulation introduction. The third one is quadratic amplitude modulation, the block diagram. The fourth type of signal sideband bandwidth, vestigial sideband bandwidth. Efficiency of AM modulation. We conclude that AM has a maximum practical efficiency of about 33% to do limited based on the modulation index. If you try to improve the efficiency by raising M, you will the signal is demodulated modulation is the only for the two requirements. So example of FM. AM, the peak amplitude of MT, and AC is the carrier amplitude. The modulation index is defined as AM by AC. This is the required condition to do the demodulation. The modulation index is the defined as the ratio of the fundamental component amplitude of the line to neutral inverter output voltage to one half of the available DC bus voltage. The modulation index hence the formula. The modulation index is the ratio of modulating signal voltage Vm to the carrier voltage Vc. The modulation index equation has the M equal to Vm divided Vc. The modulation index should be a number between 0 and 1, and when M is the greater than 1, distortion results into the modulated waveform. And the solution of modulating index is the measure of extent of modulation done on a carrier signal in amplitude modulation. It is the defined as the ratio of the amplitude of the modulating signal to that of the carrier signal. It's the value of and is the value is the kept less than 1 to distortion in the modulated signal have to demodulate and extract the modulating signal from the given data. MA equal to AM divided AC is equal to AM 50, 0.5 is equal to AM divided by 50 is equal to 25V. Then is the required conditions when the modulated signal is made defective regardlessness of the audio frequency. Over modulations the causes the waveform or envelope of the transmitter is the signal to have sharp edges or bends. According to the diagram, we can see that due to over modulation, the waves bands more than the carrier wave. Over modulation techniques of digital modulation, modulation, and spread and spectrum method. And the advantage of over modulation is that operation is one of the most important issues of PWWM converters. Over modulation strategy can effectively improve output, fundamental voltage and current, shorten the system dynamic response time, and expand steady state operation. Over modulation of power converter. The use of over modulation system transmit the signal through space to long distance. We have to remove the need for wire in communication system. The technique of communication system, the technique of modulation helped human to become wireless telephone no longer had to be plugged into the wall. Instead of AM modulation, the extracting the original signal modulated wave. The modulator is an electronic circuit that converts the information content from the modulated modulations and its types is the process of decoding the modulator signal into is the original form of three types of modulation: amplitude, frequency, and phase modulation. A demodulator is a device which can arbitrarily information carrying signal from a signal formed by varying a characteristic of a electrical or electromagnetic wave is less than infrared frequency is the information carrying signal, and the modulation and demodulation is the process of encoding information in a transmitted signal. Demodulation is the process of extracting information from the transmitted signal. Demodulation used to key process reception of any amplitude modulated signal, whether it for broadcast. Demodulation is the process by which the original information signal, the modulation is extracted from the incoming overall received signal. Then, on needs of the demodulations, the telephone receiver, a loudspeaker cannot be vibrate with high frequency. The frequency is the beyond the audible human ear. Is necessary to separate the audio frequency from audio frequency carrier waves. Encoding of information in a instance frequency of type widely used for FM radio broadcasting. It's also used and the monitoring new bonds of EEG, two-way of radio system, sound synthesis, magnetic tape recording, and system and some video transmission system. Is called frequency modulations, varying the frequency of the carrier in the line with the intensity of the modulating signal, and it's the advantages of decrease the noise and the frequency modulations. We can also reduce noise by increasing the frequency deviation rather than significant in the signal to noise ratio. It's also reduce the interference by the adjacent channel through per bands. The application of frequency, the wireless communication, audio transmission, radio broadcasting. The FM is the used for radio broadcasting and high. AFM has many applications in various field industries in the radio broadcasting, and FM and PM modulations. Frequency modulation is the widely used. Phase modulation is used. Derivation is proportion to the modulating voltage as well as modulating frequency. The advantage of FM's less radiated power, well-defined service area for given transmitted power, smaller geographical interference between neighboring station, improved signal-to-noise ratio, to man-made interference. The types of modulations: amplitude, frequency, space. Modulation is the effect is the process of changing the frequency of the carrier signal in accordance with the surface signal is the modulating signal. The difference between AM and FM in the radio wave known as the carrier. The carrier wave is the modulated amplitude by the signal that is transmitted. The or carrier wave modulated in frequency by the signal that is to transmitted. Amplitude variation in the FM. The envelope of the an FM modulated signal is a constant carrier modulating wave and modulated less to noise. Was generally is and the quality of radio reception in order to account amplitude modulation system. First, sound cue. Person FM system in where the receiver is built into hearing AID and the body worn receiver to attach the headphones. FM and wideband FM has limited frequency and handband narrowband for snaps and operating short range of frequency. The frequency of signal often the example of FM is the length of string and therefore a resulting pitch rapidly altering oscillating movement of the finger and amplitude modulation is through modulation and the phase modulation are types of what is called angle modulation. The FM and PM characteristic by their superior performance and compared to amplitude modulation in the presence of noise, in the expense of higher bandwidth requirements. Modulation is the class of carrier modulation that is used in telecommunications transmission system. The class compares frequency modulation the frequency or phase respectively of the carrier signal and to encode the message signal. Angle modulation is the angle modulation is the type of modulation in which the phase or frequency carrier wave is varied according to the instance value of the message signal, while the amplitude of the carrier is constant. Angle modulations. The first one is the frequency modulation and the phase modulations. We use the angle modulation is the several advantage and amplitude modulations such as noise reductions, reductions, improved systems, and more efficient use of power. The power of angle modulation is the total average power is the always constant and is the simply the power of carrier. And disadvantages of tools such as increased bandwidth and use of more complex circuit. And benefits of modulations, angle modulations, no signal missing others, communication range increase, multiplexing of occurs, and bandwidth of FM. The frequency of modulation index is the mostly over one, and it usually requires a high bandwidth at a range of 200 FM operate is very frequent high frequency range, normally between 18 to Deviation maximum deviation and frequency. The deviation ratio is equal to maximum deviation, maximum modulation. The application of formula F from signal is the FMT is equal to PC plus KAM cos 2 pi cos the CT plus pi. Is the where AC is the constant amplitude angle modulations and is the constant frequency angle modulation is the to be written as pi t angle angle is signal as the modulating signal is to defined as S F from T is equal to AC cos. This external frequency of the wave and the mean of frequency modulation is the encoding of the information in a carrier wave by changing FM technology is the widely used in the field of computing, telecommunication and signal processing. And the frequency modulation is the varies the frequency of the carrier in line with the intensity of the modulating signal. The FM and the PM modulation is the widely used phase in the FM derivation is the proportional to the modulating voltage only. PM the frequency derivation proportional to the modulating voltage and as well as modulating frequency. The principle of FM is the technical or process of encoding the information on a particular signal and by frequency of the modulating signal and for a purpose of or because the frequency of a noise and amplitude, FM was originally introduced radio diffusion. The example of frequency modulation signal often periodically example the rapidly finger and amplitude modulation flatted modulation modulations. Frequency modulation. The frequency of a carrier signal deviates from its the center frequency by a more proportional to the message signal amplitude. And frequency modulation uses the message signal to vary the carrier frequency within the some small range about its original value. Modulation is the signal has its instantaneous frequency that varies linearly with the amplitude the message signal. Frequency modulation system is the frequency modulation system in noisy places such as classroom. There are two main parts of this system. Computer unit and the formula of the FM modulation is that just the equation represent the carrier wave which is the another wave function. The frequency deviation is the FM is defined as the two between the minimum and maximum extent of the frequency of the signal and the carrier frequency instruments frequency change time around the carrier frequency. The receiver frequency is 87.5 and typical channel spacing of maximum frequency deviation. Some classes leaving highest and below the lowest frequency reduce impact quality. Modulation is equal to modulated frequency and to the maximum frequency of has less noise during modulating process. The noise gets amplitude modulated brings about variation only this amplitude of carrier wave does no harm and the message signal and we the frequency modulation is the technique or process of encoding information on a particular signal by varying the carrier wave frequency in accordance with modulating signal. For frequency modulating wave, frequency modulate that for conditionally communication signals for transmission. The encode same message signal as wave in the phase. Phase modulation is the one of the two principal form of angle modulations. Together with phase modulation, widely used in conjunction with amplitude modulation. Quadratic amplitude modulation uses both phase and amplitude modulation to create different binary states for transmissions. In the phase modulation in the graphical terms, the process of varying the phase of carrier signal linearly visible instance value of phase modulations and amplitude modulations, the frequency and phase of the carrier signal are kept constant. In phase modulation, the amplitude and frequency of the carrier signal are kept. Then converting the information uh, the carrier signal phase with the changes in the message signal amplitude. Linearly with the instance value of the message signal. The waveform of a message signal and the phase modulator signal are the message signal. And the carrier constant A is the amplitude constant. The message signal is the contains information or message. It is the original signal that it needs to be transmitted from the transmitter to the receiver to suitable from the communication channel to the receiver and the receiver previous receives signal which is the converted back to its original form. The message signal is the message signal to remove the noise. It also helps in improving efficiency of the signal. Signal is the baseline signal. High, higher than the message, the carrier signal sent with the message on the same communication modulation process when sent the message signal. Low frequency that output signal is high frequency. Phase modulators, the modulator, the suitable form of transmission and which is suitable mode of transmission for the communication system. This process of the PM is the similar to the FM modulation process except for the integrated FM steppers integrated before modulating signal to apply balance modulator. The integrated block of FM is present before balance modulating block, and but in the PM modulation no integrated block is required. The block diagram PM modulator circuit consists of carrier signal source balance modulator added, and the carrier signal source generate carrier. So with the carrier frequency 90-degree phase shifter converts carrier with modulator generate a double sideband amplitude modulator signal by the message and carrier signal. Application of phase modulations. In the sound synthesis, the PN is the less susceptible to noise, interference, and popping sounds, and then suitable for sound broadcasting, commonly referred to as sound digital synthesis. And the PN is the used in digital synthesizer for the generation of signal and waveform. And the widely used in a telephone communication, and due to high speed transmission. The advantage of phase modulations is the high speed. Phase modulation is due to the pulse generation at high speed, low signal power consumption. PM requires low signal power consumption due to its better efficiency and fast speed. Simple circuit design. The from it has the simple circuit design, easy modulation and demodulation. It's easy to compare P to circuit design. The disadvantage low noise immunity. Has less noise immunity than FM. It is because the frequency are less affected by external disturbances than phase. Hence, PM has low noise immunity than FM. Complex circuitry during and conversion from FM to PM. The conversion of process from frequency modulation to phase modulation is complex. It is used to additional components, and low signal to noise ratio. PM has low signal to noise ratio than FM. It is due to the higher bandwidth of FM.